In this example, I want to show you how to take the amount of one substance in a chemical equation and relate it to every other substance in a chemical equation. That's one of the neat properties of chemical equations. As long as the situation is right, and we'll tell you about what that means later, as long as the situation is right, you can take the amount of one substance in the chemical equation and relate it to every other substance in the chemical equation. This example shows you how to do that. So I've got this chemical equation, which represents the reaction between CaCO3, the active ingredient in Tums, and HCl, which is stomach acid. So when you take a Tums tablet, this is the reaction that occurs in your stomach. And the question asks, if you have 0.0075 moles of CaCO3, how many moles of HCl will that neutralize? Well, let's look at the chemical equation. The chemical equation relates moles of one substance to moles of another substance. If I look next to the CaCO3, there's no number there. That means we assume it's 1. Next to the HCl, there's a 2. So these two numbers tell us that 1 mole of CaCO3 equals 2 moles of HCl. That's a conversion relationship. So now I can convert between moles of CaCO3 and moles of HCl. So I take the number I know, 0.0075 moles of CaCO3, I put it over 1 to make it a fraction, and then I multiply by 1. But the expression for 1 comes from the conversion relationship. I need moles of CaCO3 to go away. So that means they have to cancel. So 1 mole of CaCO3 goes on the bottom of the fraction, and that leaves 2 moles of HCl on the top of the fraction. When I multiply these two fractions together, moles of CaCO3 cancel, and I'm left with moles of HCl. When I plug through the math, I get 0.015 moles of HCl. That's the correct number of significant figures because 0.0075 has only 2 significant figures. So that many moles of CaCO3 will neutralize 0.15 moles of HCl. That's pretty nice to know. But we can actually learn a lot more from this chemical equation, because one substance in a chemical equation can be related to every other substance in a chemical equation. So, given the amount of CaCO3, I can actually predict the amount of each product produced as well. So let's start with CaCl2. There's no number in front of CaCl2, so that means it's 1. So the conversion relationship that the chemical equation gives us between CaCO3 and CaCl2 is that 1 mole of CaCO3 equals 1 mole of CaCl2. So now I can convert. I take the number I know, 0.0075 moles of CaCO3, I put it over 1, and then I multiply by 1. In this case, I want moles of CaCO3 on the bottom, so it will cancel, and I want moles of CaCl2 on top. So now when I multiply these two fractions together, moles of CaCO3 cancel, and I'm left with moles of CaCl2. When I plug through the math, I find out that the answer is 0.0075 moles of CaCl2. But we can go on. We can relate the moles of CaCO3 to the other products in the chemical equation as well. Let's move on to water. There's no number in front of water. That means it's 1. So that means the conversion relationship is 1 mole of CaCO3 is equal to 1 mole of H2O. That's our conversion relationship, so now we can convert. Once again, we take the number we know, 0.0075 moles of CaCO3, put it over 1, and multiply by the fraction that has moles of CaCO3 on the bottom and moles of H2O on the top. That allows moles of CaCO3 to cancel, and that gives me 0.0075 moles of H2O. All right, one more substance to go. There's no number in front of the CO2, so that means it's 1. So we get a conversion relationship between moles of CaCO3 and moles of CO2. I then convert by taking 0.0075 moles of CaCO3, multiplying by a fraction that has moles of CaCO3 on the bottom and moles of CO2 on the top, and I learn that 0.0075 moles of CO2 are made. So what does this tell us in the end? Well, think about it. I just gave you the number of moles of one thing, CaCO3. From that, you were able to figure out the number of moles of everything else. The number of moles of HCl neutralized, 0.015, and the number of moles of CaCl2 produced, 0.0075, the number of moles of H2O produced, 0.0075, and the number of moles of CO2 produced, 0.0075. So this begins to show you the power of stoichiometry.